Now student, let's discuss about some common measuring instruments. So what we are going to discuss now? We are going to discuss about common measuring instruments. That is common measuring instruments. Student, common measuring instruments are ammeter and voltmeter, and first we will discuss about ammeter. That is ammeter. Student, current in an electric circuit is measured by an instrument which is called ammeter. So student, current in the circuit is measured by ammeter. Student, ammeter is always connected in series. It is connected in series with the resistor or device through which current is to be measured. Student, it is connected in series because we know in series combination current remains the same. So student, the same current will flow through ammeter and it will give you the accurate reading. Now student, the resistance of an ideal ammeter is 0. Resistance of an ideal ammeter is 0 because student, if an ammeter has resistance, then student, as it is connected in series, so it will get add up with the resistance of the circuit, and student, because of this the current flowing from the circuit will decrease and ammeter will not give you the accurate reading. So student, the resistance of ammeter or an ideal ammeter is 0 and resistance of ammeter should be less. Now student, let's talk about voltmeter. Student, voltmeter is used to measure voltage in an electric circuit. It is used to measure the potential difference across 2 points in an electric circuit. Student, voltmeter is connected in parallel. It is connected in parallel. Student, voltmeter is connected in parallel between the points where the voltage is to be measured. So student, it is connected in parallel. Now why it is connected in parallel? Because student, In parallel combination, we know the voltage or the potential difference remains the same, so it will measure the same potential difference which is between the points. Now student, the resistance of voltmeter should be infinite, or the resistance of an ideal voltmeter is infinite. The resistance of an ideal voltmeter is infinite. Why, student? Because if it has low resistance, then student, it will draw some current from the circuit, and student, it will not give us the accurate reading. So student, if its resistance is more, so current will not flow through the voltmeter, and student, or we can say that it will not withdraw any current from the circuit. So student, its resistance should be high, and for an ideal voltmeter, its resistance is infinite. Now student, let's draw a circuit which contains ammeter and voltmeter both. Student, ammeter is connected in series. This is a resistor which is connected to a battery giving a potential V, and voltmeter is connected in parallel across this resistor R. Student, this is the positive terminal of voltmeter and this is the negative terminal. Similarly, this is the positive terminal of ammeter and this is negative terminal. Student, positive terminal is connected to the higher potential and negative terminal is connected to the lower potential. Similarly, for ammeter also, the positive potential, the positive terminal is connected to the higher potential and negative terminal is connected to the lower potential. Now student, there are also those type of ammeter and voltmeter which can be, their terminals can be used interchangeably. Now student, I hope voltmeter and ammeter is clear to you. These are common measuring instruments which are used to measure current and voltage. Student, ammeter is used to measure current through an electric circuit, and to measure voltage, voltmeter is used. Now student, let's solve some numericals based on combination of resistors. Now student, we shall solve some numericals based on combination of resistor. Let's start with the first numerical. So the question is, in the given circuit, what should be the value of X so that the net resistance between A and B is 50 ohm. This is point A, this is B, this resistance is 30 ohm, 60 ohm, X and 40 ohm. So student, what's the question? Student, in the given circuit, what should be the value of X? We have to find the value of X for which the net resistance between A and B is 50 ohm. Now student, let's solve the question. Student, we can see here that these two resistors are connected in parallel and these two resistors, that is X and 40 ohm, are also connected in parallel. Student, first of all, let us say that the effective resistance of these two resistors be R1 and the effective resistance of X and 40 be R2. Now student, we know this R1 and R2 are connected in series. So student, R effective is given by R1 plus R2. Now student, it is given to us in the question that the effective resistance between A and B is 50 ohm. So student, R effective is 50 ohm. First we will calculate this R1. Student, we know 30 and 60 ohm resistor are connected in parallel as their ends are connected. So student, 30 ohm and 60 ohm resistor are connected in parallel. Therefore student, this R1, which is 1 upon R1, is given by 1 by 30 plus 1 by 60. We take the LCM, it will be 60, and the numerator we get 2 plus 1, which is 3 by 60, and student, it will come out to be 1 by 20. So student, from here we can see that this 1 by R1 is 1 by 20. So R1 is equal to 20 ohm. So student, we have find out the value of R1. It is 20 ohm. Now student, we know R1 and R2 in series combination give the effective resistance. So R effective is equal to R1 plus R2. We know R effective. We have calculated R1. So we can get the value of R2. R2 is equal to R effective minus R1, which is 50 minus 20, which gives us 30 ohm. So student, the resistance of X and 40 is R2, which is 30 ohm. So student, we have find out R2 also. Now we know X and 40 ohm are connected in parallel. X and 40 ohm resistor are connected in parallel. Therefore student, the effective resistance, which is 1 by R2, is equal to 1 by X plus 1 by 40. So student, we know what is R2, it is 30. So 1 by 30 is equal to 1 by X plus 1 by 40. Student, we can take this on this side and we get 1 by 30 minus 1 by 40. We can take the LCM, which is come out to be 120. So student, in the numerator we will have 4 minus 3, which is 1 by 120. So student, this 1 by X is equal to 1 by 120. This implies that X is 120 ohm. So student, the value of X is found to be 120 ohm. The value of X is 120 ohm. So student, if the value of X is 120 ohm, then the equivalent or the effective resistance between points A and B will be 50 ohm. Student, I hope this question is clear to you. Now we shall solve another numerical. Now student, let's solve another numerical, and the question is, in the given circuit, find the value of I. Student, the resistances are 60 ohm, 15 ohm, 5 ohm and 10 ohm. So student, what's the question? Student, a circuit diagram is given to us, and in this circuit diagram we need to find the value of I. So student, let's solve this question. Student, see here, in this question, total current is given to you. Total current is 1 ampere. Student, we can find out the equivalent resistance of the given circuit. Student, we have to find the current through 60 ohm resistor, and student, we know that this current I is given by the voltage across 60 ohm resistor. Let it be V prime divided by the resistance of 60 ohm resistor, which is 60. So student, if somehow we find the voltage across 60 ohm resistor, then we can find out the value of I. So let's find the voltage across 60 ohm resistor. V prime is the voltage across 60 ohm resistor. Now student, in the given circuit diagram we can also see that these two resistors are connected in series, and student, the combination of these resistors, and student, 60 ohm and 10 ohm, all the three resistors are connected in parallel combination. So if V prime is the voltage across 60 ohm resistor, then student, the total applied voltage is also V prime. So student, we have to calculate the total applied voltage. Student, we can calculate the total applied voltage V prime by multiplying this current. Let it be I prime, which is the total current, multiplied by the effective resistance. So student, first let's find out the effective resistance. Student, see, these two resistors, that is 50 ohm and 5 ohm, are connected in series. So R1, let the equivalent resistance of these two is R1. So R1 is 15 plus 5, that is 20 ohm. Now student, this 60 ohm, 20 ohm and 10 ohm are connected in parallel. 60 ohm, now 60 ohm, 20 ohm and 10 ohm are connected in parallel. So student, the equivalent resistance or the effective resistance 1 by R effective is equal to 1 by 60 plus 1 by 20 plus 1 by 10. If we take the LCM, we will get 60, it will come out to be 1, it is 3, and this is 6. We will get 10 by 60. This is 1 by R effective. So student, this implies that R effective is equal to 60 by 10, which is equal to 6 ohm. So student, R effective is 6 ohm. That is, the effective resistance of the given circuit is 6 ohm. Now student, we know that this V prime is equal to I prime into R effective, and I prime is the total current, which is 1 ampere. So student, V prime is 6 volt. Now student, we have V prime, we know the resistance, which is 60 ohm. We have to find out I. So I is equal to 6 by 60, which is 0.1 ampere. So student, the value of I is 0.1 ampere. So the value of I is 0.1 ampere. Student, I hope this question is clear to you. Now let's solve another numerical.